Can upgrading a cloud be pain-free? This we want to clarify in our talk about upgrading an OpenStack Cloud from version 6 to version 7. First, we want to start with an introduction. That's my colleague Nano Grinner. He works as a cloud developer at SUSE. And I'm Rick Zalewski. I'm also working as a cloud engineer. And I'm also responsible for the release coordination between the teams. First, we want to talk about upgrading. What is it? Challenges, then why and what, and then we come to the main topic, the non-disruptive upgrade. At the end, we'll see where it goes to the future. Yeah, let's speak about upgrading. On day one, it's usually like everyone thinks deploying a cloud is the most difficult part. You get the task from your boss or another team needs the cloud and you just started with deploying a cloud. It's usually very complex and the goal for you is the setup. When you're done with the setup, it's running, all requirements are fulfilled, then you feel good. Your task is completed and you will proceed. When we come to day two, you arrive in the morning at the office, you check your mails, and then you see a mail from the security department. They say they found a security issue in your cloud and you have to fix it, and you fixed it, and then you proceed with the normal work, and then you come again to office and you get another mail and another team needs something. Let's take the QA department. The QA department in your company needs another feature, another virtualization function, and so on. So beside all these topics, you have to install maintenance updates and keep your cloud up and running, and you need to operate it on a daily basis. For this, there are usually many tools available, so the complete tasks are easy, they are automated, and it's not a hard task. So you can do it on a daily basis, it's fine. But then on day three, there was an upgrade. There is a new cloud release. You want to upgrade your cloud, and everyone who tried doing an upgrade knows upgrading is hard. The tooling for an upgrading is not existing, or if it's existing, it's outdated for the next release, and it takes time and so on. There's usually not a good approach for upgrading. So if we conclude this, then we can say deploying is actually the easiest part. Operating and upgrading are the more challenging part, and upgrading is the hardest part. Now I'll give to my colleague Nanok, and he will give you an overview about why and what.
Yeah, thank you. We have to be careful that we don't trip ourselves here with the cables now. Yeah, now. All right. So complicated. Let's see if that works. That's like a curse. We had the same issue yesterday already before with the clicker. And it worked just 5 minutes ago. OK. Yeah, we are talking about upgrades. I guess every one of you already has done an OpenStack upgrade, or at least thought about. Just some general comments about upgrading, why we are doing that. Because in our deployment, we need to get access to security fixes or stability improvements. Yeah, that's also, it's good to closely follow upstream development to get access to new features. And it's just, in general, a good idea to stay on a supported release, so you don't have to do all the support on your own. When we are doing upgrades, we see a number of problems. For example, downtime. Updates need a lot of preparation for coordinating different teams and writing announcements and testing. Workflows need to get adapted. with new code, we can always have new bugs. It's yeah, not nice, but we know it happens. And yeah, also with complex operations, there's always the risk when something goes wrong, like we are seeing data loss or corrupted databases or something like that. And there is from the very recent OpenStack user survey, it's filed under difficulty to deploy, but it's a problem. Here, the frequent releases, but in general, that keeping up in an operational working deployment model is hard to achieve. Yeah, because for OpenStack, upgrades are a frequent necessity. Yeah, we are working on an OpenStack product. So we have customers and we see some requests from their side too. What they want in general is reduced downtime, at best no downtime and a live upgrade. They want to have the possibility to roll back or be able to cancel an upgrade if someone is not happy with the result. Yeah, everything that happens during an upgrade needs to get documented. The documentation needs to get created, maintained, delivered, and so on. And yeah, there is two things we can do, or yeah, actually, and the cadence, the upgrade cadence, they also want to have a slower cadence. So there is one thing we can do, that's skipping upgrades, releases for the upgrade. That's something that we are not really covering in this talk, though. So yeah, to come back to a bigger overview, when we have a new release, yeah, something follows that we call the upgrade marathon. We start with evaluating the release. At some point, we decide we want it, so there is planning the release, planning the upgrade, testing the upgrade. That's an iterative process most of the times. Then we are doing the upgrade, which usually comes with some downtime, following fine-tuning and integrating new features into the workflow. And with the OpenStack release speed of a new release every 6 months, there is already the next release at the door, and we can start again. Operators might decide that yeah, they want to not do the upgrade, either while skipping a release, yeah, or just not doing the upgrade. And we are working on yeah, reducing the pain there, reducing the upgrade cadence, and reducing the downtime with the non-disruptive upgrade we are currently working on. Yeah. So what we need for the process is, if we want to be non-disruptive for the workload, we need to have an HA supporting deployment, high availability support for the upgrade, for the deployment, else we are facing network downtime. We offer a number of tools for the operator for the upgrade. There is a web user interface that guides you through the upgrade, where you basically just click from step to step. But also there's a command line tool. I guess many people prefer that. And there is even direct access to the REST API, which controls step by step what happens during the upgrade. To be able to do a non-disruptive upgrade, we have a number of requirements. So of course, the system has to be up to date. All updates need to be installed. The network has to be healthy. We need a completely configured domain. Pacemaker, which is the component that's doing the HA, the high availability. The cluster has to be healthy and not in some failover mode or anything. If Ceph is used, the Ceph cluster, the storage has to be healthy too. And we need enough free compute resources available, as at some point we are migrating instances to compute hosts, to free single compute hosts. And yeah, we just need enough capacity for that during the process.
Sorry, question. Pacemaker, are you suggesting that you need to have Pacemaker actually used for your cluster? Or?
It's part of the product.
Yeah, it's part of the product, but you don't have to do HA on your control or compute
No.
But are you saying that you need to be using HA to do an upgrade?
If you want to do a non-disruptive upgrade, you need to have an HA cluster. You can also just have a classic setup without any HA support, and then you will face some downtime because while you are upgrading the OpenStack services, they are just not there for a moment. Yeah, that's also an option. That's also still supported, but the great thing is non-disruptive, only working with an HA solution in our implementation. Yeah, so we are starting with upgrading the administrator node. If you're not familiar with our product, we have an administrator node. There is a tool deployed that's called Crowbar that orchestrates the deployment and the operations of OpenStack. And then we have the OpenStack itself, our cloud, that's deployed somewhere. What we are doing is, as a first step, we are upgrading the administrator node. Later follows the rest. So first thing, the administrator node. We are firstly running some preliminary checks, basically to make sure we meet the requirements that were just defined. Also, here we decide if we have a non-disruptive mode or a normal mode. And the non-disruptive mode has HA, and the normal mode is without HA and comes with some downtime. When we begin the upgrade, and if you have other questions, then please just interrupt me. Yeah, when we begin the upgrade, we decouple the nodes from Crowbar, from the administration server. We are disabling the chef client on the nodes, and that's freezing the cloud in the current state. It's still operational, still running, but we cannot do any changes there for the time being. Changing the configuration, for example. Yeah, we are creating a backup of the admin node and a database dump. Yeah, that's optional but recommended. Always create backups. We need to update the repositories on the administrator node. That has to be done manually because there is a number of different ways how we can provide those repositories, and there is no way to guess where they do come from. So here the operator has to do it himself for the time being. We need the current SLES repositories as we are also doing an operating system upgrade. And of course we need to have the OpenStack Cloud repositories and the update repositories available. Yeah.
Is Cloud 7 only supposed to run on SU?
Yes.
So this OS upgrade is mandatory.
Yeah. Yeah. Then we upgrade the operating system for the administrator node. That's done in the background with a script and a zipper command that also stops the chef client, our assistance management tool or engine. And we are creating a dump of the current database. And as we are doing a kernel upgrade, we also have to reboot here. We are also creating a PostgreSQL database. In the previous versions, Crowbar, the administrator, was storing its data in an SQLite database. And it's, yeah, we just want to move on to a more powerful database and are using PostgreSQL. There we are either creating a new local database, or we can also use a pre-existing external database and just add the credentials and the connection for that and use that one. And yeah, we are migrating then the old data to the new database. Yeah, and then we are done with the administrator service. And what's following is the client nodes. Those, and yeah, my colleague takes over again. Yeah.
Can you run mixed versions? So can I update administrator and then wait 2 weeks and then do the client nodes update, or do I have to do that at the same time?
You can wait. The only problem is if you wait, you can't change the configuration of the OpenStack anymore, because the configuration is controlled by the administration node.
Yeah. So it would be possible, but there is, I don't really see the benefit from that. When you think about doing a partial OpenStack upgrade, like firstly upgrade one service and then wait a time and then the next service, that's currently not possible.
Yeah, but doing the administrator first and then waiting some time, it's possible. Yeah, upgrading in client nodes is the most challenging part here. Before you're upgrading, or before you should upgrade your client nodes, you want to do your usually backups. So this is the right time. There are no configuration changes anymore. So you should back up your instances if you have something important running. Then you should create snapshots to save the state where it was before. And actually, this is also the last chance to do some changes in the OpenStack resources. So you can, at this time, still create new instances or destroying old ones if you don't need them anymore. If you continue, then the first thing is what we're doing. We're upgrading the repositories on the client nodes, or we prepare them. This means we enable the /12 SP2 repositories there, the OpenStack Cloud 7 repositories, and if it's used, the high availability extension. And of course, all the required update repositories. At the same time, we automatically disabling the old repositories, so in this case, the OpenStack Cloud 7 repositories and the SP1 repositories. Before we actually should start, we disable all the irrelevant and related OpenStack services which are not required to keep your instances up and running and available. So we stop, for example, non-required APIs, like for Manila and Swift and so on. Now, after we stopped all the services, we can be sure that there are no any more changes in the OpenStack environment. So the instances keep there, and we are able to create a backup of the OpenStack database. So this will reflect the state when you need to roll back. And now this is the point where the OpenStack API will be mostly unavailable because we stopped the services. Once we prepared everything, we want to continue with the controller node upgrade. And the first thing what we do is we take a non-master node. If you have an HA setup, there are master nodes, non-master nodes, and we just take a non-master node. There are also other requirements, like where is DRBD running, if you use it, and so on. But it's not so important here. If you have the L3 router audit running, then we will migrate this router to an other node, which is not currently upgrading, to make sure that your network will be all the time up and running and your nodes will be accessible. Once this is done on this node, which we took, we will stop pacemaker, so stop everything on it, and we'll start the OS upgrade to have this also on SP2 running. Once it's upgraded, we also have to do a reboot because of the kernel upgrade. But actually, we don't want to start services at the moment. Before we do anything on this node, we will make sure that the other nodes which are not upgraded yet, that we don't make any changes there if we re-add this node to pacemaker again. For this, we have a special flag. We call it pre-upgraded role. And yeah, as I already said, this makes sure that we don't start any services on this node. And here also the core API time will start. So there is no API anymore running. And all services are affected. But your instances are still up and running. Now we can start bringing the other upgraded node up and prepare it for the operation. So we will start pacemaker, and we will upgrade all configurations that we have the newest configurations from the latest OpenStack release. In our case, it's Newton. After this, we have to make one special step, which is stop synchronizing the HA resources. So to make sure that we make changes on the network, that this is handled only by Grover and not anymore through HA and pacemaker. Otherwise, they can interfere each other, and we can have some downtime of the network. So this, we make sure that this will not happen. Once the network is up, we'll promote this upgraded node to a master node, and at the same time, we will move the pre-upgraded role, and then after this, pacemaker will start the services on this node. So this node is then able to take all the traffic and all the API calls again. So the core API downtime is over now. This is required to continue afterwards for the compute node upgrade. This is very theoretically, so I may create some diagrams to make it visual. So the first step, we have our two nodes. Still both SP1, it's a very basic HA setup with two nodes and some basic services. In the next step, as I described, we will make this one of the node free, we will upgrade it, and this means also that this node is not able anymore to take failover. So your HA setup is not anymore fully healthy. But this is in this case wanted because we need this node for upgrading. We will reboot this node, but we will not start any services. Then as next, as I already described, we'll make sure that this node keeps in the state, and we will start the services there. We promote this node to master and move some services to the new node already. The green box is an indicator for shared HA resources, so DRBD or NFS or something like this. Services which are not requiring DRBD or similar, we move next, and then as last, we move the network. But there is one special thing, that we have the network on both running first, and then we'll reconfigure this network setup to move the traffic from this node to this node, so that we don't have any network downtime here, and that you know that your instances are available all the time. Once is sure that the traffic is handled properly, we'll also move this to the new node, and then the upgraded node will handle all your controller services. And then after this, we will continue with the other nodes in this cluster, and this is really straightforward. So we'll the services on these nodes are already stopped to do this special pre-upgraded role, so we can just move forward, install. Yeah.
What if my network agents are on a separate network cluster?
Then Then we take one cluster first, and if your network stack is not on this cluster, then we just proceed. So we
still start with the control cluster.
Yeah.
Upgrading this first.
Yeah, and then as next a network cluster.
Okay, so this means once you have the database upgraded, you schema, then the old L3 agents communicate the newer database schema in your Fusion API side.
Yeah.
Okay.
We tested out it works. Yeah. After upgrading the node, we sync all the slave data with the master data, then stopping your complete cluster stack. So all what's running on this is completely stopped, upgrading the node OS and continuing. In case you have a normal mode, so without HA, there will several network outages happen. In case we move the router to a different node, or if we upgrade the network stack. Especially due to migrations, there will be downtime. So it's very similar to our previous upgrade case, where we just upgraded one node after each other, and there was also downtime. Yeah, upgrading compute nodes is the easiest part here. First, we will disable the Nova hypervisor, that Nova doesn't spawn any new instances on this node. The instances which are on this node, we will migrate to another node and make sure that there is nothing anymore running on this node. In case there is pacemaker remote, we will stop it. As on the other nodes, we will upgrade the node OS, rebooting the node, then also as like for the other nodes, upgrading the configurations and adding this node to the pacemaker cluster again. So all services are running on this node again, and the Nova is able to spawn new instances on this. Yeah, for this I have also a small diagram. So we start with one node, moving the instance to other nodes, continuing with the next node, moving also the instances there to another node, till all the compute nodes are updated. Yeah, this is a mock-up from our new UI. And as we are seeing there, it's for upgrading the controller nodes and the network nodes, and the compute nodes is one click if you want it. If you don't want it, you have just still the command line tool and can decide on your own which nodes you want to upgrade, in which order. Or if you want to do it with the API, it's also possible. What you see also in the screenshot, there are only this amount of steps which are required to update your complete OpenStack Cloud. And it's completely guided through the UI. Once we upgraded everything, there is some finalization needed. So what we are doing, we make sure that really all the configurations are updated on nodes, make sure that the orchestration is right again, and this we are doing by reapplying all our bar clamps to the nodes and bring them to the new state. Then we will show the bar clamps page, and you can do the changes on your setup if you want to use some new Newton features. This is possible now, and then we are also done with the upgrade. For the future, we can still improve this, so we can make sure that we don't have downtime of the APIs. We can upgrade services separately, so first Nova, then Neutron, and so on. And what we also want to do is, what we can do is that we can migrate also from another older setup, so from Cloud 6 and to Cloud 8 and so on. But it's just an outlook, and we're not sure when we are doing this. What we also want to do is we want to are able to cancel an upgrade from each step. So if you're also more continued already, so upgrading the controller, that you can also cancel this. And if you're not happy with the upgrade, that you can actually roll back. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Yeah. Are there any questions?
The compute node upgrade, is this optional? Because with this mandatory operating system upgrade, SU2, it requires that I have 3 resources, live migrate instances, and so on. Because in the end, it's just silver up Nova compute and the neutron of research agent. It's done. It should also run on the SU1.
It should run, yes, but we don't support it anymore. So we always support the latest operating system, which is in this case SP2. So we drop our support for SP1.
It will not stop directly, so you have a period of time.
The problem there is Grover is not able anymore to handle, or is not anymore tested to support SP1. And this is the reason why we don't support it.
One still supported by SUSE.
Yeah, but not in our product. It's supported in SUSE OpenStack. It isn't supported from SUSE, but it's not anymore supported in SUSE OpenStack Cloud because we only concentrate on the latest release.
Imagine we have a cloud with 50 compute, cannot upgrade them all.
This is really straightforward, and as long you just need one compute node which is as large as your largest compute node, and then we will make sure that we migrate all your instances around without downtime.
Yeah. So I see your problem, but is it actually like you are really running at full capacity? So you.
Yes. So
yeah.
we really, for us, it would mean we need to reshuffle 2,000 instances.
All right.
And if this step would be optional or would be done later, compute by compute.
We're doing it by compute. You can do it later, but it's not recommended because the controller is already upgraded, and we can't make 100% sure that it's really a long-term compatible between each other.
That's why it's just super up Nova compute.
This is the problem. We don't ship our product for SP1, so you will not get the Newton packages on SP1.
Will the upgrade of the compute nodes handle the compute HA that Adam and Vincent have shown here? So you're actually implementing the HA for the compute nodes, so not the controller nodes, but actually also the compute nodes. Will the upgrade handle that?
Yes, yeah, that's supported.
I guess it would probably be possible to find a workaround for your migration problem, but it's not part of the product.
Yeah, you can do it with the Cobra controller with the API, but it's then not supported. Any other questions? Okay. Then we are done. Thank you.
Thanks.